Lesson 7.2, the law of sines. So first let's start with defining what the law of sines is. So the law of sine is a way of relating the angles of a triangle to the sides of the triangle. So first let's draw a triangle. So in a triangle the sides, or the angles rather, will be capital, and then the sides of the angle will always be small letters. So the angles are the capital letters and the sides are the small letters. So the sides are always opposite to the angle which it relates to. So it will usually look like this. So what the law of sines says is that A over sine B, this is just the law, or sine A, is equal to B over sine B equal to C over sine C. So it just shows the relation, or gives you the relation between the sides and the angles of the triangle. You don't have to use all three. You can use like these two, for example, or use these two, for example. So for our lesson, we will split the law of sines into two parts. First, there's the normal case, and then there's the ambiguous case. So for the normal case, they'll give you two angles and one side. So let me put a triangle here. So by two angles or one side, I mean it can be either SAA or ASA, or the opposite of AAS, which is A, or the opposite of SSA, which is AAS. So it can be one of these three. So let's say here they're asking us to solve this triangle. By solve the triangle, they mean like get every angle and side for the triangle. So we need to get this angle, this side, this side. So we can use the law of sines to do that. So we have this angle and the angle opposite to it. We can label the triangle. So this will be A, this will be small a, this will be B, this will be small b, this will be C, this will be small c. So first we can find this angle by doing 180 minus the two angles we have here. It will be 61 plus 39. All triangles have a sum of angles of 180, so you'll always do this. So we'll get an angle of 80 here. Okay, now we can get the sides. So let's say we want B first. We can use this law again. So we'll do sine of 61 over these. This is the angle, and then over the side, which is 16.7. Then equal to the angle, which is sine 39, over the side, which is B. It's unknown. Since we're finding a side, it's okay to shift solve. So when you shift solve this, you'll get B equal to 12. So here we'll remove B and write 12 instead. And then we can do the same thing with the C, where we can write sine of 61 over 16.7, or we can write sine 39 over 12. This will be around 12. We'll just assume it's 12. Equal to sine of 80 over x. So if we do any of these, by any of these I mean this equal this, or this equal this, we should get, I have to do it on the calculator first. So sine 39 over 12 equal to sine 80 over x. You'll get x equal to 18.8, or around 18.8. So we'll remove c and write 18.8. And we solved all the sides and angles of the triangle, so we've successfully solved the triangle. If you can notice a pattern here where the greatest angle will always look at the greatest side, and then the second greatest angle will always look at the second greatest side, and then the third greatest angle will look at the third greatest side. Also, you can write the law like this, or you can write it the reciprocal way. So sine A equal to A, then sine B equal B, and sine C equal C. They'll both give you the same thing. Okay, let's move on to the next part, the ambiguous cases. So when we say ambiguous cases, they'll give you two signs and one angle. So it will be like SSA. So ambiguous means it can be one of many things. So these are the conditions for the ambiguous case. So if A is greater than B, then it's one triangle. If A is less than H, we'll explain what H is. No triangle. A equal H, one triangle. A is between H and B, two triangles. So the formula for H is equal to B sine theta, or B sine A. So they'll give, in the questions like these, they'll always give you A, small a, the side. They'll give you B, small b, the side. And they'll give you capital A. So when you get all these three in the given question, then it's an ambiguous case and you have to figure out which or how many triangles you have. Okay, let's look at an example here. So we have small a, small b, and capital A, which means we're dealing with an ambiguous case. So let's look at our conditions and deal with them one by one and see if it's any of the conditions. It should be one of them at least. So let's look at condition number one. A is greater than B. Is A greater than B here? A is greater than B because 20 is greater than 15. So it's the first case. So we have one triangle. So let's draw the triangle and solve the triangle. So this is our triangle. Then we have angle 55 and the opposite of it, which is 20. And then let's take B here. B can be either here or at the bottom, it doesn't really matter. So let's find the angles. So sine B, or actually I'll label them first. So this should be B, and this should be C. This is A, and then this is C, and this is A, or this is small a, and this is small b. So sine capital B, which is the angle, which is unknown, over the side, which is 15, equal to sine of angle A, which is 55, over its side, which is 20. And then we can just do this on the calculator. So the answer is B is equal to, or angle B is equal to 37.9 degrees. So we'll write here 37.9 degrees. And then we can find the third angle by doing 180 minus both sides, or both angles, which will give us 87.1. So 87.1 degrees. Okay, let's use law of sine again to find angle or side C. So sine 55 over 20 is equal to sine 87.1 over C. So since it's a side, we can shift solve. So sine 55 over 20 is equal to sine 87.1 over C. So C will be 24.38. 24.38. So notice how the greatest angle looks at the greatest side, then the second greatest angle looks at the second greatest side, and then the smallest angle looks at the smallest side. So here the smallest angle is 37.9, it looks at 50. It is important to know that when you're finding the side or angle using the sine law, the order on both sides should be the same. So you have to write sine, then the angle over the side should be equal to the angle over the side. So sine of an angle over the side. You cannot write sine of a side equal to side over the angle. This will not give you the right answer. Also, when you're finding an angle, for example, it is best, although like shift solve will usually give you the right answer, it is best to manually solve this. So we'll do 20 sine B is equal to 15 sine 55 then you do 20 here and 20 here and you cross it out. Then you inverse sine. So this should give you the same answer. And shift solve will usually not give you the same answer, so this is the best way, but you can still use shift solve, that is also fine. So let's move on to the next exercise. So here we have small a, small b, and then angle a. So it's an ambiguous case. So let's look at our conditions. Is a greater than b? These shouldn't have a degree symbol. Okay. Is a greater than b? 10 is not greater than 12, so this case won't work. Then is a less than h? We'll have to find h. So h is equal to b sine a. It will equal to 12 sine 38. So 12 sine 38 is 7.38. So is 7.30 or is 10 less than 7.38? No, it is not. So the second condition also does not work. Is a equal h? No. And so it has to be the last case, which we'll make sure I know. 7.38 between 10 and 12. Yes, it is the last case. So we have two triangles. So now we have to solve the triangles. Okay, so first let's draw the triangles. So I'll draw two triangles first. So this is our first triangle. This is our second triangle. And then we write the given, or the ones we have. So we have 10 or a equal 10. So this will be 10. This will be 10. Then b equal 12. We'll assume b is the left side. So this is 12. This is 12. And then a, which is the opposite of small a, is 38. So this is 38. This is 38. So the first thing to do is to find angle b on the first triangle. So we can use the sine law again. So sine 38 over the angle or the side opposite to it over 10 equal to sine of angle b over x. Then you can, or not over x, it's over 12. So b will be, I'll need to do it on my calculator, sine 38 over 10 equal to sine x over 12. You'll get 47.6 degrees. So this will be 47.6 degrees. So on the other triangle, what you would do is 180 minus the angle you have minus b will give you b prime, for example, or b for the second triangle. So 180 minus 47.6 will give you 132.4. So this will be 132.4. So to find the last angle on both triangles, you do 180 minus the other two angles. So on the first triangle, it will be 94.4. On the second triangle, it will be 9.6. So now we only need to find the last side. So we can use sine law again. So sine, this is the first triangle. I'll do the first triangle first. So sine 38 over 10 equals to sine 47.6 over 12. Oh, no, we need to find the third side. So we need to find C, which is this one. Then the angle opposite to it is 94.4. So sine 94.4. Then we just shift off. So sine 38 over 10 is equal to sine 94.4 over C. So C will be 16.19. So around 16.2. So on the second triangle, we do sine 38 over 10 equals to sine 9.6 over c. So again, we do the same thing again on the calculator. 9.6. So c is equal to 2.7. So this will be 2.7. And that's both triangles solved. Okay, let's move on to the next example. So here again, condition 1 does not match. So we have to find h. So h is b sine theta. So b, which is 12 sine 38. Make sure your calculator is on the green one. Then 12 sine 38 is 7.38. So here a, which is 6, is less than 7.38, which is h. So we have no triangle. No triangle. Okay, last example relating to the ambiguous case. So again, condition 1 doesn't match, so we have to find h. H is 12 sine 38, which is 7.38. So here a is equal to h, so we have one triangle. And again, you'll just solve the triangle like we did in the previous examples. So one last thing for this lesson is finding the area of a given triangle, which has side, angle, side. The angle is between the two sides. So we'll start with the first example. Let's say this is 12, 68, and 18. So since we have side and then angle and then side, we can use the A equal to half, then the two sides and the angle between them. Here it will be C. So 1 over 2 times 12 times 18 times sine C, which is 68. You put it on a calculator. You get 100.13. That's your area. Another way you can find the area, they'll give you the three sides of the triangle, so 12, 13, and 5. Then you have to use the formula S times S minus A times S minus B times S minus C. And here S is the half parameter, which is all the sides over 2. A plus B plus C. So let's find S. S is equal to 12 plus 13 plus 15 over 2. 12 plus 13 plus 15 over 2, that's 20. Then on the calculator, you do 20 minus 20, or times 20 minus 12, 20 minus 13, and 20 minus 15. So 20 times 8 times 7 times 5. You get 20 radical 14. So A is equal to 20 radical 14.